We've discussed how acids and bases can be classified as being strong, weak, or negligible. Well, strong acids and bases are going to be acids and bases that have extremely large equilibrium constants. And this extremely large K value implies almost 100% dissociation. That is to say, strong acids and bases are going to be strong electrolytes. While I typically don't like for people to blindly memorize things, it's really worth your effort to memorize the strong acids and strong bases simply because we'll be using them so frequently. So the strong acids are hydrochloric, hydrobromic, hydroiodic, nitric, chloric, perchloric, and sulfuric acid. The strong bases are the group 1 metal hydroxides, so things like sodium hydroxide or potassium hydroxide, and the heavy group 2 metal hydroxides. So a heavy group 2 metal hydroxide would be calcium, strontium, and barium hydroxide. For a strong acid or base, the pH or the pOH can be found directly by making the assumption that the strong acid or base dissociates 100%. That is to say, if you have a strong acid concentration or a strong base concentration, for the most part you can simply use that concentration as the H plus concentration or the OH minus concentration when doing your calculations. In practice, the water in the solution is autoionizing as well, so it's contributing some very tiny amount of H plus and OH minus, but not to really any great extent. And as long as your concentrations of acid and base are bigger than 10 to the minus 7 molar, you can ignore the autoionization of water. Now, weak and negligible acids and bases are going to have very small K values. So we can consider a generic weak acid, HA, reacting with water. This reaction would have a Ka value, so an acid equilibrium constant, or an acid dissociation constant. And remember that we omit pure liquids and solids from equilibrium constants, and water is always going to be a pure liquid. And sometimes we simplify the weak acid dissociation, and we end up with exactly the same structure for our Ka. But please be aware that whenever we use an H+, it's kind of a shorthand, because in reality, if you have an acid in water, the H+ ions are going to interact with the water to make H3O+. For a weak base reacting with water, we have this kind of expression.